Morning students. In the last video already we have discussed Faraday's laws of electromagnetic induction. In that laws you must be knowing whenever there is a change in magnetic flux linked to the coil, an induced current is produced in it, and that production of induced current will be continuing so long as the change in magnetic flux linked to the coil. Second law, it was the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked to the coil. These two laws already we have discussed in EMI in the last video. So from Faraday's law we get it, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked to the coil. So that what you are getting, that from the law that E equal to, you know, d phi by dt. You get it, d phi by dt is the rate of change of magnetic flux linked to the coil. And if the coil is having the n number of turns, and it is simply it will be reducing as n d phi by dt. But it is clearly indicates, it gives the magnitude, how much amount of induced EMF, induced current is produced, that can be calculated by help of the Faraday's laws. But it is not telling about clearly the polarity which will be developed across the coil or across the circuit. The polarity, you cannot get the direction of the current, in which direction the current will flow. That information you do not get it from the Faraday's law. And to get the direction of the electric current, direction of the induced current produced can be determined by help of LENZ'S law. So LENZ'S law gives the direction of induced current, or you can tell it gives the polarity developed across the circuit. Before knowing all these things, you know that how that polarity will be developed. Let us discuss the LENZ'S law first. What it tells, this is a very important law. What it tells, it states that the direction of induced current produced in a circuit is such that it always opposes the change or the cause that produces it. Here the sentence just simply, you just mind it here. The direction of induced current produced in the circuit is such that, because the direction of the induced current which will be produced in the circuit will be in such a way that, and it will oppose the cause which is producing it. That means, due to what reason the induced current is produced, the direction will be designed, that the direction will be formed in the coil in such a way that it will oppose the cause. This is a very important point what I am telling you. It will oppose the cause, and you will be understanding clearly on its explanation how it will oppose the cause. Whoever is producing the induced current, and the induced current, after producing induced current, that induced current will oppose that cause, oppose the change whatever is produced there. I think this sentence you must be understanding from this explanation clearly. Here already I have taken one bar magnet, and it is having south and north pole, and another is the coil. Whenever the south pole of the bar magnet is suddenly taken towards the coil, and as per Faraday's law, so change in magnetic flux is linked to the coil. That means that increase in magnetic flux is linking to the coil. So as per Faraday's law, the induced current must be produced here. So what will be the direction of the induced current? How the induced current will be produced? You know it, that induced current whichever is produced here, that induced current, due to this induced current, the movement of the north pole towards the coil will be opposed, because as the north pole, the region, which one is the cause of producing induced current? The movement of the north pole towards the coil is actually the cause of producing the induced current. So induced current, the nature of the induced current will be such that it will oppose the cause, means the movement of the north pole will be opposed, means from this side you can get only repulsive force. From this side of the coil we will be getting on repulsive force, because it is moving towards the coil and it will repel it. So how it will be possible? You know it from the coil. Suppose if the current is flowing in a clockwise direction, what will be the polarity? The polarity becomes the south. If the current flows in anti-clockwise direction, If the current flows in anti-clockwise direction, the polarity is north. You know it. The polarity is north. This is the clockwise polarity, you are getting south, and if anti-clockwise, the polarity becomes north. Means our target is that the current will be produced here in the coil in such that the polarity which will be developed here on the front face, that must be showing the north pole. If it will be the north pole, then it will oppose the north pole, movement of the north pole towards the coil. I think you must be understanding. Because as per the law, the nature of the induced current will be such that it will oppose the cause. Cause means the movement of the north pole towards the coil, that will be opposed. That means this polarity side, this side will be behaving as a north pole. If it will be north pole, means the current is flowing in anti-clockwise direction. It is clear the current is flowing in anti-clockwise direction. So you are getting the direction of the current here. Current is flowing in anti-clockwise direction. In the other sense, if you think it, if the north pole of the magnet is taken away, if the north pole is taken away from the coil, at the same time we will be getting the decrease in magnetic flux linked to the coil. That means that is nothing but the change in magnetic flux linked to the coil. As the change in magnetic flux linked to the coil is taking place in the coil, so induced current will be produced. So what will be the nature of the induced current? Means immediately it must, because north pole is going away, to oppose the behavior of the north pole. What is the behavior of this magnet? The behavior of the magnet is, it is going away from the coil. As it is going away from the coil, so the nature of the induced current will be such that it will attract the north pole. So it will be possible it becomes the south pole. If it will be the south pole, immediately it will attract the north pole. That means the current will be flowing in clockwise direction. If the north pole is taken towards the coil, the face of the coil behaves as the north pole, so that it will oppose it. If the current flows in the clockwise direction, the face of the coil behaves like the south pole. In this manner, the polarity of the circuit is immediately decided. Means if you take north pole towards the coil, again taken away from the coil, in that manner, if you just fluctuate the bar magnet towards the coil, taken away from the coil, in that time the galvanometer will be showing the deflection towards the right and left in this manner. So that Lenz's law, always it is used to determine the direction of the induced current. If you remember Lenz's law, and Faraday's laws can be written at E equal to minus d phi by dt. We are using the what? Polarity, that is minus. We are using the polarity minus, because in the last video, that from the Faraday's law, you must be knowing the magnitude of induced EMF equal to d phi by dt. It was d phi by dt. If you are giving the direction, if you are adding the direction, then Lenz's law can be written as E equal to minus d phi by dt. And if the coil has the n number of turns, we can write E equal to minus n d phi by dt. In other sense also, you can write if the initial flux linked to the coil is phi 1 and final flux linked to the coil is phi 2, and what will be the induced EMF? E equal to minus n phi 2 minus phi 1 upon t. Within the t time, the initial phi 1 is the initial flux linked, and phi 2 equal to final flux linked, magnetic flux linked, and hence the induced EMF will be equal to minus n phi 2 minus phi 1 upon t. So in this manner, you can use Lenz's law. If you solve one question basing on that induced law, Lenz's law, basing on Lenz's law. So suppose one question is that, just I would like to discuss it here. One question is, the question is that actually the magnetic flux through a coil, perpendicular to the plane is varying accordingly. Phi equal to 5t cube 4t square plus 2t minus 5 Weber. Calculate the induced current at t equal to 2 seconds if the resistance of the coil is 5 ohm. Because you know that phi equal to 5t cube plus 4t square plus 2t minus 5 Weber. It is given here. So what will be the induced EMF? The induced EMF E equal to, that is d phi by dt. That is d phi by dt, and this is equal to d by dt of 5t cube plus 4t square plus 2t minus 5. So this will be equal to 15t square plus 8t plus 2, that is E. So at t equal to t equal to 2 second, so at t equal to 2 second, what will be the induced EMF? Then E becomes, that is 15 into 2 square plus 8 into 2 plus 2, and this will be equal to 15 into 4 plus 16 plus 2, 78 volt. The induced EMF which is produced equal to 78 volt, but the resistance is given as the R is given, R of the coil is given 5 ohm, so the induced current R equal to E upon R, because you know from the Ohm's law that E equal to or V equal to IR, so that is I equal to E upon R, and that E becomes 78 upon 5, so this will be equal to 5 ones are 5, 15.6 ampere. So induced current which will be produced in the circuit is 15.6 ampere. So that by that whenever you are using you calculating the induced current, and you must have to think for the Lenz's law also. But here directly I just find out the magnitude of induced EMF and magnitude of current. In some cases you will be finding the direction of the current flowing through the circuit, that will be discussed in the next classes. Thank you.